This is the first video for MM4 area and volume. So you can see we've got example 1 for the first syllabus dot point, which is calculate the percentage error in a measurement. So when we measure things, we aren't always accurate. If I say that a measured height is 155 centimeters, in reality it could actually be half a unit above or below that. So when we're measuring to the nearest centimetre, it might actually be 155.5 centimetres or 154.5 centimetres. It's going to be half a unit above and below 155 centimetres in reality, somewhere between those two numbers. To calculate the percentage error, so it's a percentage error, so we're going to times by 100 to give us a percentage. And the actual error is half a unit over the number that we're measuring. So we measured 155 centimeters, or we think that the height is 155 centimeters. So 0.5 divided by 155. So half of the unit divided by the measurement. In example 1, we are looking at the percentage error for AB and AD. So AB is this line. So you can see that it's 2 units long. And using the percentage error, the plus or minus 0.5 part means that it could be actually bigger or it could be smaller. So green is the smaller distance and pink is the larger distance. So we're saying that this is 2 units, could actually be 2.5 or 1.5, somewhere in that range. So there's a little bit of error there. The percentage error is half the unit that we're considering, which in this case is units, divided by the length that we think it is, which is 2, times by 100, so giving us 25%. The percentage error for AB is 25%. The percentage error for AD, so we're saying that AD is 3 units long. Could actually be a little bit bigger or a little bit smaller. So we're going a half either way, half positive, half negative, which is this symbol. So 0.5 times 3. 0.5 divided by 3 times 100 to give us a percentage error. And you'll notice that sometimes you need to round your answer. When you round your answer, make sure that you actually put this in the 1 decimal place. So you need to round correctly. The purpose of example 2 is to show you that when we have squares, so when we have area or if we have volume, the errors get magnified. So the area of the black rectangle is 2 times 3 units, which is 6 square units. So the area, so we're saying that it's 2 by 3, so the black rectangle has an area of 6 square units. The smallest area would be this green one. The largest area would be this pink one. So for the green one, we have 1.5 times 2.5, which is 3.75 square units. And for the larger one, we have 2.5 times 3.5, which is 8.75 square units. So you can see that when we're finding area, because we're timesing 2 numbers together, we get a big variance in our answers. It's worth noting for some of the more complex questions.